All right, in this video, we're going to start looking at a linked list and considering how it's implemented and how we can implement it in C++. Okay, so a linked list is a data structure that's commonly used for implementing a list. And instead of an array, which holds everything contiguously in memory, a linked list breaks all the nodes in the list down into individual nodes, and then we link the nodes together using pointers. And so what I'm showing you here in this graph on the screen is a representation for what a linked list might be like in memory. So we have each of these little nodes. And so this is, so this is one node in the list, milk. This is another node in the list, eggs. And this is another node in the list, it's holding bread. And then each of these nodes in the list have a pointer inside of them. In this case, I'm calling it the next pointer. And each pointer points to the next to another node in the list. So milk beside it has a next pointer that's pointing to eggs, and eggs beside it. Beside eggs, we have a next pointer that's pointing to bread, and then bread has a next pointer that's pointing to null, and this tells us that's the end of the list, and there's nothing else in the list. And in order to look at this list and evaluate it, we're going to have some pointer in memory that we typically call the head that tells us where the list begins. And then we have a pointer tail. We don't actually have to have a tail, but it's helpful in some cases. And the tail points to the last thing in the list. So as I said, items in the list are linked together through pointers. This type of list I'm showing you where each node in the list has one pointer pointing to one other item is called a singly linked list. There's one pointer that connects adjacent items. And something you can kind of intuitively see about this is when I start at one end of the list and I follow the arrows, I can only go one direction. So this is like kind of a unidirectional linking of the nodes. So from milk, I can get to eggs, but once I get to eggs, I can't go back to milk and see what came before it. There's no pointer pointing me back. These lists can be of arbitrary size. I've drawn it here with 3 nodes, but in fact, I could point head to null if I wanted an empty list. Or I could only have one item in my list if milk was pointing to null. Or I could add lots of things on here past bread. I could add 100, 1,000, 10,000, 1,000,000 nodes in this list if I wanted to. There's nothing about the structure of the list itself that limits the number of things I have in this list. Note, this is much better than the array in that sense, right? An array is of a fixed size. I need to stay within the confines of the array. But now with this linked structure, it can grow to an arbitrary size, very easily. All I have to do is make another node and link it onto my list. Okay, and then it's critical that I know where the list begins. So I always need to keep track of the head of the list. And so an easy thing to do there is to make an object that holds the head of the list. So in this case, our list object is going to hold the head of this of all these nodes that get linked together. And we can also, for convenience, remember the tail, just to make some operations a little more efficient. Okay, so the classes we need in C++ to make a list like this, we need a list node. And this list node class, I'm just going to make everything public for now to make things simpler. But inside of the list node, I need an item. Again, the item here could be anything. I could use a type def to say that an item is an integer or a string or something else. And then also it needs a pointer to the thing that comes next in the list. So in this case, the pointer is to another object of the same type. So right, this is class list node, and then it's going to have a pointer called next that points to another list node. So this list node star tells us it's a pointer to another node of the same type. And then just for convenience, I have a constructor inside this class that will initialize item for me and set the next pointer to null. So that anytime I make one of these, it's just set up in a convenient way. Okay, the other thing we need is the overall list object that keeps track of the head of the list that we're currently creating. And so the head of the list is a pointer to one of these list nodes, and we'll call it head. We'll also make a pointer to a list node called tail. And then within this list object, there are a few functions that we might, want our list to implement, like appending to the list, removing from the list, and checking if the list is empty. And as we go, we're going to implement these functions, but as we go, we'll implement more functions as well. This is just getting us started in our list implementation. The list constructor. So the way I'd want this list constructor to work is I would want, when I make a new list, I want to make an empty list. And the way we designate that a list is empty and has nothing in it is to set head to null, or to null pointer. And so over here in my code, I initialize the head and tail member variables to be null pointer. And that's all we need to do. After we do that, the list is constructed. Okay, now how about appending an item to the list? Let's think about how that would work. So when I start out, I have an empty list and both head and tail are null. But then when I want to add a new item to my list, like milk, then I'm going to make a new list node object somewhere on the heap, and I'm going to connect it to my to the head of my list. And then what I want to have is what's shown here below in the dotted box. I want my head pointer to be pointing to the list node object, and in tail, when there's only one item in my list, the head and the tail are the same thing, and so the tail will also be pointing to the list node object. So this is what I want to have happen. So when I call the append function and I give it an item I want to add to my list, there are a few things I'm going to do. First, I need to make a new list node, and I pass the item A in as an argument, and that will initialize my list node object to hold item A, or a copy of A in this case. And it also sets its next pointer to null, right? We saw that in the constructor on the previous page. So here, when I make a list node, it sets item equal to A, and it sets its next pointer to null. Okay, so this first line of code, it does this. It makes this list node containing milk and setting next pointer to null. And then since my list object is null, I need to take some special actions. So if my head is equal to null pointer, which it is, I want to link in my list node. And the way I do that is just by setting head equal to node and tail equal to node. And please note that node is the variable name I used for this list node I just created that holds milk. And so I just set head equal to node and tail equal to node, and then I get this structure here. And I'm done. That initial list node is linked into my list. However, I might have a more complicated situation. I might already have a node in my list. And if I already have a node in my list, then the code's going to work similarly. So let's say now I'm adding eggs onto the list where I've already added milk. Okay, so the first thing I do, the first line of code here in append, I'm going to create a new list node called with eggs in it. And node again will be pointing to this new one. Okay, and then since head isn't null anymore, I need to take a different set of tasks. And one thing I need to do is I need to connect milk to eggs. And then I need to update the tail to reflect the fact that now eggs is the last thing in the list instead of milk. Okay, so this first line of code, tail next equals node, it takes care of linking milk to eggs. And the reason I say tail next equals node is because I want eggs to be at the end. So tail will always point to the last thing in my list. And so, whereas head will always point to the first thing in my list. And so I don't want to use head here, even though I could, even though head next equals node would work this time, it wouldn't work the next time when I have two things in my list. But the tail will always point at the last thing. And so I say tail next, right? So tail, I follow the pointer to next, and I set tail next equal to node. And so that's going to draw this arrow from the next field to this new list node I just created. So this line of code here, tail next equals node, establishes this line. Okay, and then the next thing I need to do is set tail to point to the new tail, which is eggs. And so I just say tail equals node. And that updates this pointer in my list object to point to the new thing at the end of my list. Okay, now if we did this again, if we added another thing to the list, what we would find is that these two steps continue to work. And they continue to work because I just need to add something on to the tail, right? I'll just need to say tail next equals something new over here, And then again, I'll just need to update tail to point to this new thing. So these two lines of code continue to work as I add new things to the end of the list. This code will not let me add to the beginning of the list. This code would not let me add to the middle of the list. This append function only allows me to add a new node to the very end of the list. Okay, but it shows us how that works. Okay, in summary, a linked list is a data structure that holds data in nodes by linking them together using pointers. Pointers give us flexibility in how we connect the nodes together. And it allows our list to kind of be small or to grow to a very large size. We created a list node class to hold each item and a list class to hold the head and tail of the linked list. We also looked at how we could implement an append function for adding nodes into our list. And in the next video, we're going to implement some additional functionality.